Welcome to this week's Center of Math problem of the week. So for this week's problem, we want to count how many different ways can we select two non-empty disjoint sets from a set of n elements. So say we have n elements. We're going to do a quick trick for this, and then we'll see how the answer kind of falls out. So say we have so many objects. Each object will assign either 0, 1, or 2. And this labeling 0, 1, and 2, 0 means it's a member of no set, 1 means it's a member of some set A, and 2 means it's a member of some set B. And so the amount of different ways that we can put these objects into two disjoint unique sets A and B, or neither, is 3 to the n. So say we have two sets A and B, and we want to count the number of different ways we can put objects into these sets A and B. And we could possibly put no objects in these sets. So that's 3 to the n different ways. So now, with this quick trick of labeling 0, 1, and 2s, we're almost done. We just need to note that we're counting a couple things we don't want to count. So we're including the possibility of empty sets. So when we're putting the objects, we can have every object be 0s, or every object be none of the sets, or every object be 0 and 1s. So the number of different ways that B is empty is, we'll see, is in fact 2 to the n. So the number of different ways we can have set B be empty is 2 to the n. And this corresponds to every object being assigned a 0 or a 1. So either in neither or either in A, but never in B. And this is similarly for A, and we also have, for when it's in neither sets, we have one case, so then everything's just 0. So number of ways where B is empty is 2 to the n, number of ways where A is empty is also 2 to the n, but the number of ways where both are empty is 1, and so now we're going to do a little bit of inclusion and exclusion. So we want to count all the sets except for where 1 is empty. So we do all the ways of counting, 3 to the n minus all the sets we don't want where 1 is empty, and then add back the intersection of these two where both are empty. So add back 1. And so here we count the number of sets where neither of them is empty. So 3 to the n minus 2 times 2 to the n plus 1 means neither is empty. And now, very last step, we don't care about sets being labeled A and B. So now here, they're labeled A or B, and we differentiate between the two, but we don't want to do that. So to get rid of that, we just divide by 2, saying set being an A is the same as the object being in B, and vice versa. So to get our final answer, we just divide this by 2. And so final answer, 3 to the n plus 1 over 2 minus 2 to the n. And that gives us our solution. Thanks for watching. Please check out centerofmath.org and check out our blog, and also follow us on Facebook and Twitter. Thank you.